All right, welcome to this week's Ronin seminar. This week we've got Gill Ragsdale, who is going to talk to us about epigenetics and the evolution of trust. Go for it.
Okay, hi there, John. This is a slide that in the last year, I've been starting all my talks with this slide, so apologies if everybody recognizes it, because I'm very interested in cultural and social adaptations to stress. But my focus particularly today is how this impacts ideas about trust and the evolution of trust, and perhaps gene culture and evolution of trust. And so this little girl, this is the photo of a little Syrian girl on the Turkish border, and the Turkish photographer is trying to take a picture with a telephoto lens, and she thinks it's a gun. She thinks he's trying to shoot her. So clearly her feelings of trust have been adapted, probably not just temporarily, but as we'll see, they've probably been adapted for life. She's just not going to be very trusting going forward from this situation. So what is happening here? Let me see. There's going to be three main parts to this talk. I'll talk a little bit about the biology of trust, some of the ways in which it's epigenetically regulated so that trust can become an adaptive response to different circumstances, and how that might support gene culture coevolution of social trust towards the end. So it kind of builds up to this end point. Getting back to the beginning, oxytocin, I think we all know the love chemical. Most people have heard about oxytocin, the love chemical, and a lot of people have some vague idea that it might have something to do with trust. And it's entered the popular consciousness. I mean, you can see it has, because these are real adverts for oxytocin nasal spray. You can really buy this stuff, because in experiments, when you use it experimentally, one of the reasons there's a lot of work on oxytocin is you can spray it up the nose. It's one of those experimental drugs that's quite easy to administer and quite easy to use. So here it's being sold to make people more trusting and improve relationships. And there's another version, I haven't put the picture on, but basically it's about how to get women to trust you for not very good reasons. And when you do these tests with oxytocin, I mean, you get some quite interesting effects. There's a lot of economic game playing experiments using oxytocin. If you intranasal oxytocin will make you more likely to invest money in an unseen partner, someone you don't know who they are, with no guarantee of return, and you'll continue to invest even after they betray you. So it really does increase trust there. When people perceive trustworthy behavior, their brain releases oxytocin, and that in turn leads to trusting and trustworthy behavior. So trust begets more trust, but of course mistrust begets mistrust. Our ability to understand and infer the intentions, the thoughts, the feelings of others is improved. Not all good news, though. There are all sorts of odd uses and odd things with oxytocin, so people shouldn't be kind of rushing out to spray it around too quickly. For example, it tends to promote in-group bonding at the expense of out-group bonding, which is not a particularly helpful thing in society. So biologically, oxytocin is kind of at the center of a hub of neurotransmitters and hormones here. But they're very, very interconnected. So that it's influenced by the sex hormones, testosterone, estrogen. But actually what that means and what kind of sex differences are is really not very well understood. It interacts with dopamine, the reward neurochemical that's implicated in reward, cortisol, stress, and serotonin, serotonin is the most researched neurochemical anywhere in the world because of its role in depression and its role in antidepressant medication, which targets levels of serotonin. So there's the good thing about that is there's lots and lots of data, and there's data all over the world. You've got a lot of stuff to draw on, and I'm going to be concentrating on oxytocin and serotonin, particularly serotonin for that reason, because there is a lot of data that you can start to pull together about this. So what does it do? I mean, oxytocin, the main route here is you've got a part of the brain, particularly the amygdala, also the midbrain, the striatum. This is where you process fear and reward, and fear and trust are not compatible. So if you can decrease the activation of the amygdala so that the response to fearful expressions, fearful triggers is decreased, then our whole behavior, not just in, this is the brain, this is a human brain, but in other mammals as well, the tendency to approach, to be pro-social rather than avoid, be risk averse, is increased, you're more likely to go forward. And serotonin as well also increases trust, and it does various things. For example, it seems to control negative emotions that can sabotage trusting behavior. So there's a few ways in here, but these two chemicals do seem to have real effects on trust, and they do seem to act on measurable impacts on the way that the brain operates. So what do we got here? So what that builds a sort of a basic idea that you've got the phenotype. What do we see? What we see is trusting behavior. It's affected by levels of oxytocin and serotonin. Got stress. Stress tends to decrease those levels, and social support tends to increase those levels. So those are environmental inputs. You've also got genes that impact on the levels of these things. There are no genes for oxytocin or serotonin. They're just little monoamines. They're not proper proteins. But there are genes for proteins that control those levels. So, for example, the oxytocin receptor gene and the serotonin transporter gene. There are different versions of those genes. There are alleles. So you can have slightly different versions of those genes, and that will influence the levels of these chemicals. Both of those genes that I just mentioned are also they're epigenetically regulated. So you can have two different versions of the genes which might have a different effect, but you can also have the gene being epigenetically regulated, which means that the gene doesn't necessarily, whether the gene is the same or different, you can turn it up or down, so it just makes more of the protein that it's supposed to make. And there are several ways you can do that, but the most well understood mechanism is a very simple one, really. It's you just pop a little methyl group at the promoter of the gene where it's going to start being read, and that will usually tend to turn it down or off. So when it's methylated, you'll make less or no protein at all. And usually some form of stress in your environment or in your bodily stress is the trigger to set this methylation mechanism. You also get histone acetylation and RNAs, and also there's quite a few other things now, but this is the one that's really more well understood, and this is where the data is on how this regulates these genes. So these genes have different alleles, but they also have this extra layer of regulation. So it gives you quite a lot of even if with just two kinds of a gene, you've got a lot of possibility here in what could be in the phenotype, what you could see in levels of trust with this. You've got quite a range of possibilities. So for example, when you have that little oxytocin receptor gene and it is methylated, perhaps you get an increase in the amygdala to the response to fearful faces. And we just said that the response to fear diminishes trust. So when that gene is methylated, you get less oxytocin and you get an increased response to fear and less trust, and you get antisocial. It's associated with antisocial behavior in teens, and it's associated with risk factors in the family, substance abuse, extremely severe harsh parenting, various things like you might expect are associated with this. These are the kinds of this family and intense social stress is associated with methylation of this gene, so that the child and adolescent and the adult are going to be less trusting than they would otherwise have been. So this changes the model that we were looking at before. So instead of having these, you've got your phenotype, trusting behavior, you've got your levels of oxytocin and serotonin. Now instead of having these two separate influences, which are genes and environment, they're now totally wedded together because the environment acts directly on gene expression. The stress in the environment, balanced with the social support, which can buffer against the stress, determines how these genes are expressed and the degree of gene methylation. To show you exactly how this works, the serotonin gene has one example of this where it's been worked out in some detail. So what happens is you have two versions of the serotonin gene. One is short, one is long. It's not a lot longer, it's just a bit longer. You've got a short and a long one. So the blue, think of it as the short blue one and the longer yellow one. Your blue people and your yellow people. People kind of figured there was something going on here, that there seemed to be some differences in levels of depression depending on whether you had this allele, but it was complicated and people couldn't get to the bottom of it. Caspian in New Zealand did a big study And he said, let's factor in some other environmental issues here. And so he looked at not only whether people had the short or the long allele, but whether they'd experienced really severe life stress. And he found that if they'd had abusive childhoods or 3 or more instances of really severe stress in their lives, they had this massively increased risk of depression if they also carried the blue shorter alleles. And if you're a female and have this very severe stress in your early life, then your risk of depression is 8 times as high. It's about 4 or 5 times if you're a male. So if you didn't have any, if you put the people in one environment and they've got a mixture of the blue alleles and the yellow alleles, you wouldn't, if the stress levels are all the same in their lives, you wouldn't even notice, you wouldn't realize that they had these different effects. You only see the effects of this when you find that they've got all this stress in their lives. You find that one is susceptible, one seems to be very sensitive to stress, and it kind of raises the question of why on earth would that have developed? Why was this? It's not rare. These alleles are not rare. So why is this happening? It's a bit unusual, but the interesting thing is that it's not all negative. There are some positives as well. It's not just so much a sensitivity. It's not a vulnerability gene. Really, it's a sensitivity gene. People with the blue shorter allele are actually very sensitive to social stimuli. So when people are nice and people are socially supportive, they actually get more back from that. It's more rewarding. It's easier to buffer their stress with social support than it is for people who have the long allele. So it actually works at both extremes. There's some cognitive processes that they seem to be slightly better with. For example, they're better decision makers in financial games. There are some gains to be had. So we're starting to see some reasons why in some situations it might be useful to have the blue allele, the short one. So it's not rare. So people have looked at this comparatively with primates, and there does seem to be, you can find groups of primates vary in terms of whether they have a shorter or longer allele for the serotonin transporter gene. And it does seem to match up with differences in their behavior. So what you tend to find is that the short alleles are favored when conditions, in particular social competition, fluctuates. It changes quite rapidly in the short term over generations. So when you've got intense social competition, hypervigilance is going to be selected for. It's going to be useful, and it's going to have survival benefits. But you don't want it to persist when the competition changes and it's more relaxed. So because these short allele characters, they're more sensitive to positive changes in social signals, it means that they're able to switch more flexibly from hypervigilance to being more trusting and more pro-social. So having that short allele genotype makes you better able to adapt in a situation where social stress and competition is fluctuating, it's changing. You can become hypervigilant, but you can also respond very quickly to social support and switch back again. And there's some evidence from macaque populations that they do have these different allele frequencies, and there are differences in the profiles of competition and aggression in the groups. So there is some idea that this does give you the idea that you can get population differences, that you can see the differences in group behavior, not just individual behavior, but actually group behavior. And that's interesting because we have something in humans, in human culture, which we call not just individuals trusting each other, but the phenomenon of social trust, which is measured in cultures and societies. And if we have a look at that in human societies, there's a lot of interest in researching about social trust because it's got a very, very strong relationship to economic development and wealth and measures of happiness, as it happens as well. When you make a transaction to do work and you expect payment, that's only sustainable if you have supporting levels of social trust. You've got to be sure that someone's going to pay you for the work you just did. So levels of social trust impacts culture in a lot of ways, wealth and GDP. So it's like credit is the economic manifestation of trust. And this little slide shows you, if Swedes are very, very trusting, apparently. The Northern Scandinavians are apparently very, very trusting. And if you adjusted everybody else's GDP and assumed that they had the same level of trust as people in Sweden, you can see that, for example, the GDP in African countries would go up by over 100%. And most countries, even a lot of the European countries, would gain something from having their levels of social trust improve. So there's a lot of interest in how do you do that if social capital in the form of social trust is so useful. What can we do to improve that? So looking more at human cultures and how this operates, there's something in cross-cultural psychology and economics as a phenomenon called extreme response style. It's a cultural response to harsh, demanding climates and economies, and it's characterized by low social trust, risk avoidance, and intolerance of uncertainty or ambiguity. Depends also on the context in terms of resources. So it also depends whether you have wealth. Because if you've got wealth, you've got resources to meet the challenge of being, for example, in a climate that's very demanding. So the ability to make good on social capital of trust depends on the availability of resources, such as wealth, to meet the ecological demands, such as climate stress. Cognitively, we think this requires a reappraisal of the risks as challenges, depending on the context, and then you can move away from intolerance of uncertainty and ambiguity. So you can see this is what they tend to find. Now you can take this relationship and you can map onto the same data. You can map on these short and long, blue and yellow, happy and sad people allele frequencies, and you get this. And when you do this, you find that that relationship we looked at only holds true for populations who don't have much of the short allele. That is, they carry less of the socially sensitive allele. Because in those populations, trust is higher in challenging habitats, and it's mediated by an increased tolerance for uncertainty. And a possible explanation for that extrapolates, if you take it from the individual to the group level, so that under stress, populations with carrying a lot of the short allele are more likely to view the situation as negative and threatening. And they tend towards risk minimizing and avoidance behaviors, where the long carriers are more likely to view demands more flexibly. It's going to depend on other available resources. So if you're a long allele carrier and you've got other available resources, it seems that perhaps they are more able to do that reappraisal of the risk as a positive challenge, and it can facilitate trust and cooperation. So they're not locked into seeing this as a really challenging and stressful situation. They can reappraise it. You can recall that the short allele carrier has had some superior cognitive skills, such as better decision making. But although they're better at financial decisions in economic games, they're also more risk averse. So it may be that they are unable to make that switch to reappraising a risk as a challenge, even when they've got the resources that could meet it. It's what some life coaches like to say is rephrasing a problem as an opportunity. So do we see this? I mean, do we see this in populations? Is there any evidence for this? And there is some evidence for it. So if we look at this map, this is a map of collectivism and individualism. So collectivist societies are ones in which they have a lot more emphasis on social and collective decisions, social institutions, and the values and the goals of the individual tend to take second place to those of the group. Whatever that might be. It might be a state, might be a culture, might be a group of some sort. And individualist cultures tend to have personal values and goals as at the top, and collective goals lower down the priority scale. So of course, I mean, not surprisingly, in the West, America and Europe, Scandinavia are highly individualist cultures compared to Eastern countries and African countries actually as well. Now you can also map, there's quite a lot of data about these allele frequencies, these short and long allele frequencies, because there's a lot of interest in them for a lot of research being done in that way. And they do definitely differ. And the Eastern collectivist cultures have very high short allele frequencies, 70 to 80%, which is twice what you have. So on the Western countries, you've got about half the frequency of short alleles. So that immediately made people a bit interested to think, well, is there some reason for this? Why are they so much easier? Is there a reason why they're different? So have the population differences in short and long allele frequencies come about by neutral processes, or is there some selection going on? Is it an example of different solutions to the same problem? Different solutions to different problems. So collectivism in Asia is also associated, as we can see, with high short allele frequency. And there's some evidence that the increased social support that you get in collectivist cultures might buffer against the increased risk of stress, vulnerability, and depression. Because actually, Asian cultures seem to have lower prevalences of mental health issues, especially depression, despite carrying an allele that we know is a risk factor for depression. So it might be the social support aspect of collectivist cultures buffers against the risk. And it may also have other cultural consequences affecting the interplay between social trust, ecological stress, and economics. So it begs the question of if that's happening, of what came first. Was it the selection for the short allele, or was it collectivism as a cultural trait? And that then benefited short allele carriers more than L carriers? How does that relate to fluctuating social stress? These are quite interesting questions. It would be interesting to have a look more closely at the low social, low S allele, low trust, low wealth collectivist African populations for this question. But interestingly, there's some other corroborating evidence. We also talked about the oxytocin receptor gene, and that has alleles which are associated with different levels of trust, and they also vary. They vary east to west in exactly the same way that the serotonin alleles vary. And that, so you're starting to think that this perhaps isn't just some kind of random drift at this point. And that would support a gene culture coevolution model involving social trust. And for example, there's and it may operate at subpopulations. For example, there's an intervention, very recent intervention in the US, that provides social support to families at risk of substance abuse and other problems. And it's been found that this intervention, which is mainly a form of social support, is more effective with families where the targets are short allele carriers. They get more benefit from it because it's a social intervention. And they also find there's less oxytocin receptor methylation. So this is, it's actually a measurable effect. It's something that it's not intangible, it's not tiny. So there appears to be a network of genes that are epigenetically sensitive to stress, and possibly social stress in particular. And for short carriers, it may be less about trust in general even than trust radius. It's about how far do you trust. You trust those people, you have intense bonds with the people that you trust who are in your group perhaps, or in your immediate group, your radius of trust, but you don't extend it further. So there may be quite a lot of difference in the way that they culturally represent trust in that way. And so it raises some issues about social policy with subgroups where you have issues about stress and you're trying to have interventions which may be targeting social support, or perhaps trying to raise people's economic profile. There's quite a few things that kind of pop out from this. And as a kind of a summary, you've got these different relationships. You've got an epigenetic regulation that enables you to adapt more rapidly to conditions, much more rapidly than normal gene selection. Gene selection is slow, and that's always been a problem for gene culture coevolution models. Is how does that happen when culture moves so fast and genetics moves so slowly? But epigenetics doesn't move slowly, so it's a much faster model than the classical gene culture model. So it's got a lot more explanatory power, much more possibilities. You can have the same allele. In this case, one of these genes had two alleles, but you don't need two alleles. You can have the same allele to influence traits differently, depending on the context. And so multiplying the possibilities. And as I said, this applies to subcultures in probably more than it does between cultures. In fact, once you start to measure it, due to things like socioeconomic status within cultures, this is going to be happening. And so it has implications for social interventions and social policy that want to increase social capital. And that is basically my talk for today.
Well done. Thank you.